In the zone of its star Proxima Centauri, this discovery has generated a wave of excitement and curiosity worldwide. Could this be the moment when humanity discovers that it is not alone in the universe? The road to this momentous discovery began with meticulous observation by NASA's powerful telescopes, which have been monitoring distant stars and planets for signs of life. Proxima B has always been a leading candidate in the search for extraterrestrial intelligence because of its Earth-like characteristics and its proximity to our own solar system. The signal detected is distinctive and unlike anything astronomers have ever observed before, marking what may be a possible turning point in human history. The implications of such a discovery are profound and far-reaching. First, it confirms the long-standing scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguingly, it raises the question of the nature of the civilizations that might reside there. Would they be mere microorganisms, representing only the most basic form of life, or could they be advanced beings possibly capable of interstellar communication and even travel? This signal from Proxima B is not simply random noise or a natural cosmic phenomenon. Rather, it carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams of researchers and astrophysicists, are now tasked with deciphering this mysterious message. They are trying to understand its content and the intentions behind it. The global scientific community is abuzz with theories and speculations about the possible content of this message. Is it a guide, a greeting, a warning, or something completely unimaginable? News of this discovery has gone far beyond the confines of the scientific community, sparking debates on social media platforms, in government briefing rooms, and at dinner tables around the world. People are looking up at the stars with renewed wonder, pondering the possibility of beings who might be doing the very same thing on a distant world light years away. How similar or different might their world be to ours? What would their society be like in terms of technology, culture, and values? This possibility seems as vast and open-ended as the universe itself. In addition, this detection opens up a number of ethical and existential questions. How should humanity respond if the signals really do come from intelligent beings trying to communicate? What protocol should we establish for interstellar diplomacy? And most importantly, how would such a discovery change our understanding of religion, life, and our very identity as human beings? While excitement continues to grow with each new analysis of the signal, there's also a palpable wariness. Cutting-edge scientists at NASA and other space agencies are working diligently to validate these findings, ensuring that the signal is not a false positive or a misinterpretation of natural cosmic phenomena. We are potentially on the brink of what could be the most significant discovery in human history, so the next steps must be taken with precision, caution, and a deep sense of responsibility. The world waits expectantly for more detailed analysis. The detection of alien signals from Proxima B not only propels our scientific efforts into a new era but also unites us with a collective curiosity and hope. We could finally be on the brink of answering one of the oldest and most profound questions known to humanity. Are we alone in the universe? In April 2019, a radio signal was detected coming from outer space, specifically from the Proxima Centauri region, which lies approximately 4.37 light-years away from us. Although this may seem like a considerable distance by Earth standards, it is actually the closest star system to our own Sun, being only about 3 times farther away than the third brightest stars visible in our night sky. The signal comes from a triple star system composed of the binary pair Alpha Centauri A and B, and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the two stellar companions, are relatively close to each other and are quite similar to the Sun in size and brightness. Alpha Centauri A shines with a yellow light and is about 1.5 times brighter than our Sun, while Alpha Centauri B has an orange hue and is half as bright. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is somewhat smaller, meaning our Sun fits neatly between them in size and output. But where did the signal between these two stars come from? The groundbreaking Breakthrough Listen project, which is dedicated to searching for extraterrestrial communication in the universe, has named this signal Breakthrough Listen Candidate 1 or BLC-1. This project, which has received approximately $100 million in funding, has employed thousands of hours of observation with state-of-the-art telescopes located all around the world. The signal was specifically detected by the Parkes Radio Telescope in New South Wales, Australia. This observatory was pointed toward the Proxima Centauri region, the closest star to our Sun. Remarkably, the signal almost went unnoticed amid the vast volumes of data collected over countless hours. Yet, somehow, the scientists managed to identify it, like finding a needle in a cosmic haystack. For the signal to be considered relevant and significant in the search for extraterrestrial life, it must meet two definitive criteria. First, it must be limited to a small frequency range, as such radio signals are not typically produced by natural mechanisms in space. Second, the frequency of the signal must fluctuate according to the relative motion of the exoplanet with respect to Earth. To verify this, scientists had to analyze nearly 4 million individual signals captured by the telescope in Australia. After an exhaustive process of filtering and eliminating unnecessary signals caused by terrestrial interference or known cosmic sources, they were left with about 5,000 distinct signals. Among those, one stood out, a signal that simply could not be explained. After cross-checking with contemporary radio transmitters on Earth to rule out any human-made sources, this unique signal, with its narrowband technological signature, only appeared when the telescope was directed toward Proxima Centauri. It was observed over a 30-hour period and exhibited a pattern consistent with the orbit of an exoplanet. Upon further analysis, the origin was determined to be Proxima B, an exoplanet that was discovered by astronomers in 2016 using the radial velocity method. This method detects variations in a star's position caused by the gravitational pull of orbiting planets. The star will wobble slightly, describing a small circle, and researchers use extremely sensitive spectrographs to follow the light from that star. The spectrum of starlight shifts slightly toward blue as the star approaches the planet and toward red as it moves away. When this shift occurs repeatedly and regularly over days, months, or even years, it is accepted that the variation in light is caused by the gravitational tug of an orbiting planet. On closer examination, Proxima B turns out to be very similar to Earth in several ways. It has a radius approximately 1.1 times that of Earth and a mass about 1.3 times that of Earth, indicating that it is a rocky world with an equivalent density. However, there are also significant differences. The first and most striking is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star, sitting at only 0.05 astronomical units, whereas Mercury, the closest planet to our Sun, is 0.39 astronomical units away. This proximity would ordinarily make Proxima be an extremely hot planet, but because Proxima Centauri is a dim red dwarf, the planet receives only about 60% of the energy that Earth gets from the Sun, placing it within the habitable zone where life could theoretically exist. There are countless unknown planets scattered throughout our universe. So far, astronomers have discovered an impressive 4,935 confirmed exoplanets, and they recently added 65 new planets to that tally, bringing the total to 5,000 known planets. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a significant milestone in planetary exploration. The James Webb Space Telescope, JWST, is now taking center stage as the most advanced telescope ever built, being 100 times more powerful than its predecessor, the Hubble Space Telescope. With its help, scientists hope to unlock the secrets of this vast expanse of the universe. In the past, we have discovered a wide variety of planets, from small, rocky worlds similar to Earth, to gas giants larger than Jupiter, as well as extremely hot planets and those located in the habitable zone. Among these discoveries, a few stand out in particular. Kepler 1649c is one of the most promising planets whose characteristics are very similar to Earth. In fact, it is the most habitable planet discovered to date and could possibly harbor life. So far, astronomers have identified 55 Earth-like planets, but they have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially thanks to the capabilities of the James Webb Space Telescope, who knows what more we will be able to achieve in the near future? Wouldn't it be amazing to find a planet truly capable of supporting life? One of the main goals of the James Webb Space Telescope during its first year of scientific missions is precisely that, to find and study extraterrestrial worlds beyond our own solar system. It focuses on how they form and the possibility that they can contain water and biological life. Webb's research into star and planet formation allows us to link studies of mature exoplanets to their birth conditions and, in doing so, better understand how our own solar system came into existence. Webb's infrared capabilities are ideal for revealing how stars and planets form for three peculiar but essential reasons. Infrared light penetrates dust extremely well, it detects the thermal signatures of young stars and planets, and it indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 20 times denser than visible light, which is especially important when observing newborn stars that are hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the earliest stages of star formation, when gas and dust are still contracting to give birth to young stars. But there is much more to the natal clouds of stars than that. Both young stars and giant planets begin as huge, swollen structures that gradually contract over time. As newborn stars get hotter with age, giant planets cool down. However, both emit more light in the infrared spectrum than at visible wavelengths, which means the Webb telescope will be exceptionally well suited to finding new stars and planets and helping us understand the physics of their formation. Webb's MIRI instrument will also search for hot molecular gas near numerous young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, much of the James Webb Space Telescope's early science work will focus on determining how planetary systems build molecules that may be crucial to the emergence of life. The implications of the James Webb Space Telescope's observations reach far beyond the confines of any single detection or anomaly. It represents humanity's most potent eye turn toward the unknown, a silent sentinel drifting in the void, searching for faint whispers from the cosmos. One of its most exciting upcoming initiatives involves the study of Proxima B's atmosphere, a task previously impossible due to limitations in spectral resolution and light-gathering capability. But now, with its infrared sensitivity and unprecedented precision, the JWST is poised to examine atmospheric compositions of potentially habitable exoplanets in great detail. Scientists hope to identify biosignatures such as methane, oxygen, ozone, and water vapor, chemical clues that might hint at biological processes akin to those on Earth. If these signatures are found in the right ratios, it could be the most compelling indirect evidence of life yet discovered. Yet, amidst this optimism, the search is not without its challenges. Red dwarfs like Proxima Centauri are known for their stellar flares, which can bombard nearby planets with radiation capable of stripping away atmospheres. A key concern among astronomers is whether Proxima B, despite being in the habitable zone, retains a thick enough atmosphere to support liquid water. Some simulations suggest that magnetic fields and geological processes might protect and replenish atmospheres even under harsh stellar activity. If Proxima B has such protective mechanisms,